All right, I'm back again. I'm hoping to get through a couple of examples here, a few more on regression lines in section 7.2. So here we go. You have a regression analysis on a bivariate set of data with n equals 100, with x bar equals 40.6, and y bar equals 66.5. You obtain the regression equation. Here we go. With the correlation coefficient of r equals 0.804, you want to predict what value on average for the response variable will be obtained from a value of 160 as the explanatory variable. What is the predicted response value? And notice here it says y equals. So there's lots of independent, dependent, response, explanatory. Essentially here we're given an x and we're asked to find the y. So over here there's a lot of extra information. What I really want to know here is the slope, 0.924. and the y-intercept, and I'm going to go old school here using m and b, 4.733. Now essentially we're saying x is 160, and what is y? And so I'm going to say here y equals, we take m, multiply by x, and add b. This is classic y equals mx plus b from algebra, maybe algebra 2. And we make a prediction accurate to one decimal place, 152.6. So kind of a lot of extra information just to tell us make a prediction. So again, deciphering the important information, put them together here, multiplying. You don't necessarily need to use Excel, but it's a fine tool for this. Here's another one with dependent and independent variables. Now we had a stipulation. We don't want to necessarily speculate outside of our data set, but we don't know, so we'll just do it and let it ride. I'll go through this one here. Notice as we look at this, 2 is here. We have a value for it, but we're using this model to estimate, and 4 is in the range here. So if I just kind of want to do it, I guess I can do it on a clean sheet, maybe. Zoom in a little bit. But again, we're given here m 1.33 and b, the y-intercept, 14.03. And we want to make a prediction when x is 2, and then also when x is 4. So again, our first y is going to be equal to m times x. Okay, got to go here, and then I'll just move down one since it doesn't like it. Plus, well, b. I'll fix this here. Not exactly sure what's happening. I think it has more to do with me recording here, but m times x. Oh, okay, I see. We just copied over this guy here. Okay. Took a little bit to get there, but if I click inside these cells, you have C3 times C6 plus C4. There we go. Not so super easy. There. Similarly, finding our second y value, m times our y value here. We go over and then click up here and add our slope. So making a prediction, I almost grabbed the whole thing. It would just give me the exact same number again over there. So estimate 16.69 and 19.35. Those will just take those out, their accuracy there. Now we have another one here. This is similar to one earlier where we plotted these, but now we have to use make a prediction. I'm going to ignore that one and kind of go through one of these more large examples, just in case it is problematic. So run a regression analysis on the following bivariate data with y as the response variable. Find the correlation coefficient and report it accurate to 3 decimal places. So take this data, copy it, paste it, special. Here we go. R is the correlation coefficient, And we can use the Corel function here in Excel to grab it. Just our first and our second data set. And again, that's our correlation coefficient. Accurate to 3 decimal places, 758. Now we have a question here about what can be explained here. This is our r-squared value, and essentially our r-squared value is really just squaring our r value. And that's the work. They ask us to report it as a percentage. I might zoom in just a tiny bit. So we just have to make this decimal to a percentage with 1 decimal place. So 57.46 would go to 57.5, not 2. There. Based on the data, calculate the regression line, round to 2 decimal places. So if I grab the data set and insert a scatter plot, I can then go here and add the trend line. With some more options to display it on the chart. And now I have a trend line. Make it a little larger. Round to 2 decimal places, 0.78. X plus 17.51. Predict what value for the response variable will be obtained from a value of 49.9 as the explanatory variable. Use significance level alpha equals 0.05 to assess the strength of your correlation. We're going to just kind of ignore all of this extra stuff and just figure out what our value here is. So I'm going to go ahead and use the decimal places of accuracy I have here. And I notice I just made a mistake here, over here. This is x plus, and notice over here this is a minus. I need to change this to a negative here, and I added a negative to my slope here. So to find my y value when x is 49.9, maybe I'll move y a bit further down and see if that helps. I need to do m times x plus b, and then rounding that to 1 decimal place, 21.16 is going to go to 2, and we'll see how we do here. At least one part is incorrect. Oh no, it's this one, the predicted response variable. Well, what did I mess up? 7751, negative 50.12, 49.9. I'm wondering maybe if I need to put these just to 2 decimal places in case that's what we have here. Let's say, yeah, 21.4. Let's see that, see if that works. Otherwise, yeah, apparently I need to use the rounded values here. I guess that would make sense if I entered them in this part of the equation to use them for this part of the equation, but that goes against a little bit of what we've been doing all along. Feel free, if you can make a mistake like that, to message me. As long as you can send me your work, I can bump up that credit for you. So, all right. Well, there's a few more examples, and I think that's all of the types. So you should be well equipped to get ready now and do the lesson. Let me know if you have any questions. Again, we're using Excel as the tool here, and just plotting it, and then adding the trend line and using that to do the lion's share of the work, or the shortcut way. Good luck.